All right, folks, it's Bass Action back in action here. In this video, we are going to review some equations of lines and slope and just some algebra skills that we're going to need when we get into chapter 3. So let's start up here on the top looking at some horizontal and vertical lines. These are really critical lines for you to understand because they will often make the problems easier than you might initially expect. So let's first jump into our horizontal lines. Horizontal lines will always look like, meaning they're going to have a particular form, and that form is always going to be y equals, and it'll just be a number. Okay, any number, but it'll just be y equals a number, and a horizontal line always has a slope of 0. Now, a vertical line is always going to have the form x equals a number. It won't have anything else. It'll just be x equals a number, and its slope is always going to be undefined. Now, we want to be careful to not ever say no slope. Vertical lines have a slope of undefined, and horizontal lines have a slope of 0. That's very important that you be very specific with that. Now, horizontal lines in our next blank, horizontal and vertical lines are always going to be perpendicular to each other. And as you'll see in a bit, these are going to be a lot easier for us to work with for some of our problems. So let's take a look at this example 1 and example 2. Let's say we want to write the equation for a line and it's going to pass through a certain point. Now, it's always helpful to draw just a little sketch, just to get an idea of where the point is. So our point is the point -3, 7. So we just want to stick it here in this proper quadrant. Now, if we want to write the equation for a line that's going to be parallel to x equals 5, we know that x equals 5 from up here above is a vertical line. Well, parallel to that means that it's going to be another x equals equation. So if it's going to be an x equals in this nice vertical line, it's going to pass through that point, and it's going to pass through that x coordinate. So our equation would be x equals -3. We can look at the parallel to the equation y equals a -12. Well, y equals just a number is going to be our form of our horizontal line. So that means that the line parallel to that is going to certainly look like another y equals a number, a nice horizontal line, and it will pass through the y coordinate of that point, so y equals 7. So we can also take a look at the same idea. We're going to have a point, so let's just make our quick little picture here. So we'll have our nice little sketch. We're going to put our point into the proper quadrant. I always think that's very helpful to visualize. Now, if we want to be perpendicular to x equals -3, we know that x equals is a vertical line. So if we want to be perpendicular to that, our new equation is going to be a y equals. So y equals is going to be a nice horizontal line. It's going to go through that y coordinate of a -10. On our next one, we want to be perpendicular to the equation y equals 21. So it's a horizontal line. Our perpendicular line is going to be an x equals then, and we're going to want it to look like that vertical line passing through that x coordinate, so x equals 7. So it's really important for you to understand that the horizontal and vertical lines have this particular form, what their slopes are, and that they're always perpendicular to each other. Now, the next thing that we want to look at is our finding slope algebraically. You would have done this in your Algebra 1 days, but we just want to do a quick little review of slope. So first of all, we always denote slope with an m. So our slope is going to be rise over run. That means the change in the x value, or the change in the y values, divided by the change in the x values. Now, it doesn't matter what point you call point 1 and point 2, that makes no difference, but the consistency that you do your subtraction is very, very important. So the change in y, that's our rise, over the change in x, that's our run. Now, parallel lines will always have equal slopes or same slopes, and perpendicular lines will have opposite reciprocal slopes. And we're going to see this in some examples here in a moment. So let's just jump down here and let's start calculating some slopes. Now remember, it doesn't matter which point you call point 1 or point 2. You can kind of choose. And I tend to go back and forth. I just try to avoid working with negatives if I can. So I'm going to calculate this slope, and I'm going to start by doing the difference between my 7 and 3. So I'm going to do 7 minus 3, and then I'm going to do my 9 minus 2. See, I almost even said it backwards as I drew it. So 7 minus 3, I have to keep that same order when I do the x's, so 9 minus 2. That's going to give me a slope of 4/7. Now, since parallel lines have the same slope, that means that the slope of the line parallel to this one is also going to be 4/7. Perpendicular lines are going to have opposite reciprocal slopes. So I know that if this slope is positive, my perpendicular slope needs to be negative, and I need the reciprocal. Let's look at another one. We're going to find our slope. This, again, it doesn't matter what order you do your subtraction. So this time for my y's, I'm going to start with the -1 and then go to the -3. So I'm going to have -1 minus a -3. We'll clean that up in a moment. And then we'll have 2 minus 5. Now, I like to clean this up. The minus the negative is, of course, going to make that a plus. So I'm going to have -1 plus 3 is going to give me a positive 2. And then 2 minus 5 is a -3. So this slope is going to be negative. The slope of the parallel line is going to be a -2/3. The slope of the perpendicular line, since this one is negative, will now be positive. And then I'm going to flip that fraction upside down for the reciprocal, and I'll have 3/2. On the next ones, what I want to look at is something special on each of these. And I want you to notice on C and D that I've got something unique happening here. On C, the y coordinates are the same on each of the points that I'm given. And on D, the x coordinates are the same on each of those points. Now, mathematically, that's going to give us something interesting and something unique that is going to help us, and we'll tie into what we did at the beginning of this video. So if we go to calculate our slope, I'm going to start with, of course, the difference in my y's. So -4 minus a -4. I'm going to rewrite that as a -4 plus 4 to help me keep track of that a little bit easier. And then I'm going to have 5 minus 3. That's going to give me 0/2. Now, we always want to simplify our fractions. So if they would reduce, we want to reduce them. In this case, 0/2 is 0. Now, we know from up above that a line with the slope that's 0 should be horizontal. And if you visualize or even physically graph these 2 points, you would see that sure enough, they would make a nice horizontal line. So that means that any line that's parallel is going to have a slope of 0, and any line that's perpendicular is going to have a slope that's undefined. Remember, we don't say no slope, we say undefined. Now, if we do our next one, difference in our y's, so we're going to do 4 minus 1. Difference in our x's, -5 minus a -5 is -5 plus 5. That's going to give us a 3/0. Now, of course, we're not allowed to divide by 0, so that means that this slope is undefined. And a line that's perpendicular to this would be horizontal, and it would be a 0 slope. And again, if you graphed these points, if you just made a rough sketch, you would see that they would in fact make a nice vertical line. So even if you didn't catch it automatically from the beginning, it would end up coming out mathematically. Next thing that we want to do is review a couple things that we actually reviewed at the beginning of this year, but are going to become very important in our next unit. And that's solving equations that are working with fractions. We don't want to have to add or subtract fractions. So what we want to do here is we want to always remember to clear our fractions by multiplying by the least common denominator. So in this case, the smallest number that both 2 and 4 will divide into without giving a remainder is 4. That's our least common denominator or least common multiple. So I'm going to multiply this entire equation by a 4. So what that means is that I'm going to take this 4 and I'm going to distribute it way over to here. So 3/2 times 4 What I understand is that if we write this out, I'll write this one out in the long way for you. What we're doing is 3 halves, really 3 halves x, times 4 over 1. Now when I do that, 2 goes into 4 2 times. So that means that when I distribute this 4 here, what I'm really going to end up with is simply a 6x. Now, when I distribute my 4 to here, of course, that's going to give me 2 times 4, or 8. When I distribute my 4 here, these 4's will cancel, and I'll just get a 5. And of course, it was an x, so 5x. And then I'm going to distribute my 4 again, and that's going to get me a 24. Now, certainly the multiplication that I wrote out here, you could write that out for each distribution that you do. For me, that becomes a little bit much. It's not necessary. I can kind of mark out in my head, but if you would like to write it out, you can. What you should notice is that at this point, all of your fractions should be gone and you should have nice whole numbers. Now, we might still get a fraction answer, but it's going to make our algebra a lot easier for us. Subtract my 5, that's going to give me a nice x. I subtract my 8 from each side, that's going to give me a 16. This one turned out pretty nice for us. Now, where this really comes into play is solving a system of equations. We are going to use this extensively in Chapter 3 and Chapter 5. What we want to notice on this problem is that both of the equations are set up to equal y. If each of these expressions, each of these right-hand sides equal y, then that means that they can be set equal to each other because they are the same. So we can start this off and say a negative 3 halves x plus 29 equals 1/12 x plus 41 over 6. Now this is a pretty intimidating equation to look at, but if we take this entire equation and we multiply it by that least common multiple, least common denominator of 2, 12, and 6, we could multiply everything here by 12 over 1. Now, we're going to start distributing. If I take 12 and I multiply it by 3 halves, 2 goes into 12 6 times. So in the next step, I'll have a negative 3x times a 6. Then I'm going to distribute my 12 to the 29. Now this one we can just multiply in our calculator if we want, or I'm going to go ahead and write this one out. 29 times 12. I'm going to distribute my 12 again. Now my 12, my 1 over 12 and my 12 over 1 cancel, and that's going to give me just an x. And then I'm going to distribute my 12 again. 6 goes into 12 2 times. So in the next step, I'm going to have 2 times 41. Now, continuing that algebra, at this point, it becomes a whole lot easier to do. I have a negative 18x plus 348. I'm just using my calculator. X plus 82. Keep solving. I'm going to end up with a 19x here. Moving my negative 18 over, I'm going to move my 82 to the left. That's going to give me 266. And my answer for x is 14. Now remember, on a system of equations, I need an x and a y. So I need to take this value for x and substitute into one of my equations. It doesn't matter which one I choose. I'm going to choose my top one. I'm going to say a negative 3 halves times 14 over 1 plus 29. Working that out gets me a y value of 8. So my final answer needs to be written as an ordered pair, 14, comma 8. The 8 is coming from right there, and my 14 came from my first step. Okay, you're going to have more practice to do with this, but remember, this is going to be a very, very critical process for you to be able to do to be successful in Chapter 3 and Chapter 5.